impedance can be written as a function of the load impedance and ABCD. And this is done in this way. So you insert a current in the input port and you measure the response, which is voltage. Voltage over current is input impedance, and this is what you will find if you will derive it. If you really want, you can put your time in deriving it, but you know, we did it on many times before. I think it is correct what is here on the sheet. Output impedance, you can do the same. And you find this expression. Now let's look at the formulas. Let's look at these expressions and try to say something about it. Let's say I want to make, let's try to understand this voltage amplifier again. I want to make a voltage amplifier. And for the voltage amplifier, we needed to make A unequal to 0 and B, C, and D 0. So A unequal and B, C, and D 0. So the input impedance is infinite. Now, not a surprise, a similar way. Let's make the output impedance of a voltage amplifier. Voltage amplifier should have 0 output impedance. So 0 output impedance. We said we need to fix A. So B and D are 0 and C is 0, but A is not 0. So ZO equals 0. So you could also, with these two formulas, design a voltage amplifier. Look, because we need to have a combination. ZI needs to be infinite. ZO needs to be 0. So, and how do we get that? Well, then you will arrive at the same conclusion. This can only be done if C, B, and D are 0 and A is finite. Unilateral means that, look at this formula. If you want to have a ZO that does not depend on ZS, on the output impedance, then divide this by B. You have D over B times ZS plus 1. And here C over A times ZS plus 1. So then you end up with this, that A times D must be B times C, and then ZO does not depend on the input impedance, and the other way around is exactly the same. So now we can put it all together, all the knowledge that we have from the modeling of amplifiers and the types of amplifiers. And here they are. The voltage amplifier. We want to have infinite input impedance, 0 output impedance, and we have the conclusion A must be 0, B, C, and D must be 0. A must be finite, sorry, B, C, D must be 0. And here you find them all 9. So, and if you look at the list, then we have here 4 parameters, and the number of combinations that you would have here is 16, and we have only 9. The other one we will discover later, because they are not unilateral, and this we designed this 9 based on the fact that they are unilateral.